You're listening to This Week in Cardiology from theheart.org, Medscape Cardiology. This podcast is intended for healthcare professionals only. Any views expressed are the presenter's own and do not necessarily reflect the views of WebMD or Medscape.
You can now access the latest in medical news on your Amazon Alexa-enabled device. Join me, Perry Wilson, every weekday morning for Medscape Medical Minute, where I highlight the top medical stories of the day. To add Medscape Medical Minute to your flash briefing, search for Medscape Medical Minute on Amazon and click Enable. Or open the Amazon Alexa app, go to Skills, search for Medscape Medical Minute, and click Enable. Then say, Alexa, what's the news? Or Alexa, what's my flash briefing? I hope you'll join us.
Hi everyone, this is John Mandrola from theheart.org Medscape Cardiology. And this is This Week in Cardiology for December 16th, 2022. This week, blood pressure control over the long term, Omecamtiv Mecarbil, incentives in Goodhart's Law, and open science. First, some announcements. Normally, This Week in Cardiology takes 2 weeks off during Christmas, New Year's, but I'm going to do a bonus this year. Next Friday, we'll have a brief recap of the year. I've published my top 10 column, and we'll discuss some of the notable studies of the year and also some honorable mentions. Then I'll take New Year's week off and return the first week of January. And thank you, everyone. It's been a great year. I'm so glad that we got to meet some in person this year. Okay, so first topic, blood pressure control over the long term. Literally, and I mean literally, every clinic day, at least once, blood pressure control comes up. It's a number, and people love numbers. And I need to apologize. I missed an important study in October regarding the longer-term results of the SPRINT trial of 2 blood pressure targets. JAMA Cardiology published this study, but let's first recap the SPRINT trial. New England Journal of Medicine published this in 2015. More than 9,000 patients with hypertension and increased cardiovascular risk, but no diabetes. The average age of these patients was 67, and nearly a third of patients were over age 75. The 2 targets, systolic blood pressure target of 120 versus 140, and a primary endpoint that was a composite of MI, ACS, stroke, heart failure, or CV death. And over 3.3 years in the intensive arm, there was a 25% reduction in the primary endpoint, and this included significant reductions in MI, heart failure, and CV death. And even overall death was reduced. However, the absolute risk reduction was only 1.6%. And adverse effects were higher in the intensive arm, 2.5% versus 4.8%, including hypotension, syncope, electrolyte abnormalities, and AKI. Now, there was a nice editorial in 2016 by Ortiz and James, and I'll link to it. And they quoted, for every 1,000 patients like those in SPRINT, there would be 16 persons who benefit, 22 persons who were harmed, and 962 would be not benefit or harmed. Now, when SPRINT came out in 2015, there was intense controversy. And one of the debate topics was the manner of blood pressure taken in the trial. Was there an attendant or not? Because if there was no attendant in the room with these automated blood pressure cuffs, people felt that this would result in lower blood pressure. Other limitations were that the SPRINT trial was open label, so whenever things are open label, there's always the potential issue of performance bias. And finally, there was at least 5% missing data. Okay, now to the paper in JAMA Cardiology looking at longer-term all-cause and CV death with intensive blood pressure over the long-term follow-up of SPRINT. Now, the first author of this paper was Byron Jager. This was a secondary analysis of the trial in which the authors did extended observational follow-up for death via the National Death Index in the 5 years after SPRINT closed in late 2015. Now, this included only a subset of the SPRINT, about a third of patients that were in this sub-study, 3,000 versus the total of 9,000 in the main trial. Now, recall that in the randomized part of SPRINT at 3.3 years, there was a 34% reduction in CV death with the intensive arm and a 17% reduction in all-cause death. But at 8.8 years in this sub-study, There was absolutely no difference. So there were also no differences in systolic blood pressure. The mean blood pressure in the intensive arm had now gone up to 140 millimeters of mercury. So the authors of that paper concluded, quote, "The beneficial effect of intensive treatment on cardiovascular and all-cause mortality did not persist after the trial. Given increasing outpatient systolic blood pressure levels in participants randomized to the intensive treatment following the trial, these results highlight the importance of consistent long-term management of hypertension." Okay, my comments. Now, the reactions among many were that basically, y'all do better. Clinicians do better, systems do better, and the editorialist, Daniel Jones, called these results disappointing. But I'm going to disagree. I don't think they're disappointing. I lead with this study because I think it highlights the difference between what can be done in studies and trials and what can be done in real life. I mean, take the blood pressure measurements, for instance. Hypertension trials rightly standardize the way they take blood pressure. They take 3 blood pressures with an automated cuff. Now, attendant or no attendant, normal clinicians don't do that. I've never seen that. I don't know if it's possible. Now, Sprint also had intense follow-up, right? There were research nurses. These don't exist in real life. Sprint also enrolled patients who were well enough and wanted to be in trials. And again, many patients we see don't have the capacity to be in a trial. They might not even have a ride to the clinic. Now, I have no doubt that with Sprint-like patients and Sprint-like care in a trial, you can drive down cardiovascular events over the short term. But remember, this came at a cost of increased adverse events, even within the confines of the trial. Now, adverse events would surely be increased in the real world if doctors got too aggressive with blood pressure meds without the follow-up that you get in a trial. I want to point to another paper. Franz Messerly and Spiro Bangalore said it beautifully in the American Journal of Medicine, the Green Journal, in May of 2016, and I'll link to this paper. I want to quote them because it's a beautiful quote. "We should remember a simple but inescapable truth in medicine. Patients are genetically, physiologically, metabolically, pathologically, psychologically, and culturally different. Accordingly, there never will be only one way to diagnose and treat many medical disorders, including hypertension. To lower blood pressure of all hypertensive patients uniformly to less than 120 millimeters of mercury clearly has to be considered absurd, regardless of the Sprint results." My friends, I'll remind you and close with this. The big bang in hypertension is treating patients with severe hypertension, like those in the Black Barbershop study, for instance. Messing with very aggressive, too low blood pressure targets in very older, frail patients can be a lot like Icarus flying too close to the sun. Okay, second topic, Omecamtiv Mecarbil meets the FDA. Omecamtiv Mecarbil is a novel first-in-class cardiac myosin activator, and from here on, I will just call it OM. And remember, it's a positive inotrope. FDA recently held an advisory committee meeting, AdCom meeting, on its approval. Now, FDA has the ultimate decision, but the agency often asks an advisory committee to render guidance on appraisal of the evidence. Now, I've been on an AdCom committee for Vernicalen, and it was a great experience because of the depth to which the evidence is looked at. At this AdCom, FDA reviewers present their review. They also release documents ahead of time, and for OM, their review was negative. Now, more on that in a minute. But also, they noted safety issues with the drug. One was that the drug, if approved, would be dosed by drug levels, which is a big issue in the real world. And there also seemed to be more troponin releases and higher cardiovascular deaths in patients in the trial who had atrial fibrillation at baseline. Anyways, the FDA panel met and voted 8-3 that the benefits of OM do not outweigh the risk for patients with HFrEF. Now, I covered Omecamtiv Mecarbil on June 3rd TWIC podcast. Let's very briefly go over the evidence, but first, let's recall the difficult history that positive inotropes have had, right? Dobutamine, milrinone, for example, have not improved outcomes, which is counterintuitive, isn't it? I mean, a problem with heart failure with reduced ejection fraction is poor contractility, so you would think drugs that increase contractility would have helped. But therein lies the entire basis of evidence-based medicine. Things that should work, say because they move a surrogate marker like a blood level or an ejection fraction, may not work. And the obvious answer is always that the human body is complex. And if you want to know what works, you have to randomize and measure clinical outcomes, not surrogate markers. Well, sorry for that aside. The Galactic HF trial of Omecamtiv Mecarbil, OM, versus placebo in patients with HFrEF, they did that. They randomized patients, more than 8,500 patients, and they had different doses of the drug versus placebo. And during the nearly 2 years of follow-up, the primary endpoint of first heart failure visit or CV death occurred in 37% of patients in the drug arm versus 39% of patients on placebo. The hazard ratio was 0.92, so that's only an 8% relative risk reduction, and the confidence intervals range from 0.86 to 0.99, and the p-value eked by at 0.03, so barely significant. Now, the next step after the primary endpoint is always to go to Table 2 and look at the components of the primary endpoint. In this case, cardiovascular death was not different, and there were a lot of cardiovascular deaths, 19% in each group. Heart failure events were lower in the OM group, but it did not reach significance. Now you look at secondary endpoints. Quality of life is measured by the KCCQ. That was not different. Again, OM is supposed to be a positive inotrope, so you'd expect people to feel better, but they did not. All-cause death overall came out nearly identical. Also this year, a second study came out on this drug, Omecamtiv Mecarbil versus placebo, called Meteoric, and I'll link to that. JAMA published this study, and it was of exercise capacity in patients with heart failure with reduced ejection fraction, OM versus placebo, and they did VO2 max treadmill testing, and the results were clear. No significant effects on exercise capacity. So in sum, we have a new drug, no effect on quality of life, no effect on exercise capacity, no reduction in CV death, overall death, and a statistically fragile, tiny effect size in an outcomes trial. Even Amgen, one of the makers of the drug, bailed on it last year. Quote, the big biotech walked away, passing the rights to the program back to Cytokinetics in November. That ended a nearly 15-year collaboration. Now, in the summer, Galactic authors published a sub-study of the main trial in which they looked at a subgroup of patients with low and normal blood pressure and found that the drug seemed to help those with low blood pressure. And two of the authors of this European Heart Journal paper were industry employees, and it turns out that the FDA reviewers were not persuaded by any of the attempts at subgroup analysis, and I say, good on them. Now, this drug is slated for a decision in February from the FDA. We've learned over the past years that FDA can go against their advisory committees. But if approved, you can expect the marketing train to go full steam ahead. And the doctors will then have to decide. The history of cardiology, ability to shun low-value dubious interventions doesn't make me optimistic if this drug does get past FDA approval. Here I think about CardioMEMS and Watchman. Third topic today, measuring the quality of care. JAMA has published an important paper on the folly of trying to measure the quality of doctors. Now, before I say anything about the important paper, first author Amelia Bond from Weill Cornell, I want to say two things. We should strive to have the highest quality doctors, but we should also strive to avoid soft thinking. Policymakers must never fail to read the economist Charles Goodhart, who stated, quote, when a measure becomes a target, it ceases to be a good measure. Now, as the largest payer in U.S. healthcare, Medicare has proposed and embraced the notion of pay for performance, which can be translated to all manner of catchy slogans like pay for quality instead of quantity, for instance. The most recent paper in JAMA assessed the actual performance of a program called Merit-Based Incentive Payment Systems, or MIPS for short. Well, the authors did a cross-sectional study of 80,000 primary care doctors who participated in the merit-based program. They then just created 3 groups of docs based on the MIPS scores, how well they did. And they had 3 groups. They had doctors who had really bad MIPS scores. They had doctors who had medium MIPS scores, and they had doctors who had good MIPS scores. And for the main outcomes, none of this mattered when you looked at real outcomes. Quote, MIPS scores were inconsistently associated with outcomes. For instance, low-scoring MIPS doctors had significantly better performance on ED visits, but worse performance on all-cause hospitalizations, and there were no differences in 4 other admission categories. And for instance, 19% of physicians with low MIPS scores had composite outcomes performance in the top quintile, while 21% of physicians with high MIPS scores had outcomes in the bottom quintile. And the authors concluded thusly, quote, these findings suggest that the MIPS program may be ineffective at measuring and incentivizing quality improvement among U.S. physicians. Okay, I want you to go to the editorialist, J. Michael Williams, who I don't know, but this was an amazingly great editorial. He started with the issue of sloganeering. And I like this quote, though it's in JAMA speak, so I'll translate to normal speak after I read it in JAMA speak. Williams writes, extrinsic financial incentives applied to measured aspects of quality can detract attention and resources from harder to measure but important aspects and undermine the intrinsic motivation of clinicians to do what they think is best for patients. Okay, the translation to normal speak, foolish quality measures worsen quality. Now, that's because doctors have a bank of attention and energy. The more you fill it with incentivizing foolish surrogates like how many of your patients get screening hemoglobin A1Cs or mammograms, you distract from real doctoring. In fact, I would submit that if we did real doctoring wherein patients were educated about the tiny or zero effect size on overall survival, plus the potential adverse effects of many of these process measures, fewer patients would accept them. That is, good doctoring, through a shared understanding of medicine, might make a doctor look worse on these foolish measures. Okay, J. Michael Williams goes on to point out that the last decade of data on quality measures is replete with quote-unquote damning evidence that has consistently found little to no improvement, even on target measures, and revealed plenty of cause for concern. He then points out that the pay-for-performance technocrats, now that's my term, not his, contend that it's the measurement design. Give us more time and we can find a better system to measure and incent quality. But Dr. Williams rebuts this, again, in JAMA speak. While there are undoubtedly refinements that can be made, particularly in the case of the impressively flawed MIPS, the intractability of the drawbacks long recognized in the economics and management literature should not be underestimated. My translation, A, read Goodhart's law. B, understand human nature. Now, what I have trouble deciding is if the technocracy of people who push these distractions onto doctors do it because of, say, conflicts of interest, say relationships to quality measurement organizations like JCO or ABIM, or they do it because they didn't get enough time on playgrounds with other humans. Here is J. Michael Williams again. To err may be human, but to overlook human is to err. Of course, he then eases ever so slightly into Hayek territory. In the Constitution of Liberty, which is a must-read, by the way, Hayek argued that no one person or persons have sufficient wisdom to control markets. He believes sort of in a collective wisdom of the markets that would, of course, come out in a totally free market. Now, J. Michael Williams, on harnessing the collective wisdom of actual doctors who see real patients, quote, the potential gains from doing so are substantial. Strategies for leveraging peer motivation, cultivating collective wisdom to support decision-making, and engaging clinicians in system change could have wide-ranging and lasting effects that extend well beyond the specific behavioral modifications achieved by these scripted nudges. Now, he might be talking about physician-owned organizations, or at least physician management systems, maybe not. He then moves to competition. He believes that it's not just competition for patients, but for clinicians and for the ability to bring new models of care into the market. Quote, the makings of quality improvement may not be as alluringly obvious as paying for quality instead of quantity. For example, tougher antitrust measures, limits on non-compete provisions in physician employment contracts, and technical assistance from payers to ease market entry of promising delivery models. In the end, we go back to the MIPS, and of course it should end. That's an easy decision, but the real issues for the future are major system changes that are way, way above the folly of measuring who checks boxes better. I really like this editorial in this paper. It's important. The editorial is unusual in its courage. It makes you think about big issues, human nature issues, and the downsides of a technocracy that puts profits above quality. To any of the young U.S. clinicians who listen, this is an important topic for your future. Okay, final topic today is a beautiful one. Open science and the arterial conduits for heart surgery. I want to start with one of the best papers I have ever read. I mean ever. And it's from a group of Brian Nosek from the University of Virginia. First author on this paper is Raphael Silberzarin. The paper is called Many Analysts, One Data Set, Making Transparent How Variations in Analytic Choices Affect Results. And the journal that was published in is one you don't read normally. It's called Advances in Methods and Practices in Psychological Science, and it was published in 2018, and I'll link to it. This paper, in this group, they brought together 29 teams of data scientists to analyze one data set. Now, it happened to be soccer statistics from Europe, but it could have been any data set. Their one question was simple. Were soccer referees more likely to give red cards to dark-skinned toned players compared to light-skinned players? The 29 teams of data scientists, experts, could use any analytic method they chose. They could even brainstorm together. In fact, they ended up choosing about 29 different ways to analyze this one data set. And boom, slightly more than 2/3 found a statistically significant positive association, and 1/3 did not. And again, these were expert statistical teams. It was one question, and it was the same data. This thing shocked me because when you read a study, they report one analytic method, not 29. But here was a paper showing that the results, for at least statistical significance, could turn on the choices made in an analytic method. The paper never really took hold, perhaps because they asked a social science question instead of something more technical or medical. But this week, we were treated to an amazing example of how this could work in a medical study. Now, of course, the main reason this could work turned on open science, and here is what happened. This summer, a distinguished group of academic heart surgeons published a sort of combination meta-analysis of 5 coronary bypass trials, CABG trials, trying to answer the question of how different conduits worked for bypass. Now, don't get bogged down in the details of bypass. I'm not a heart surgeon, and you probably aren't either. The story is about open science and how results can turn on choices made and how you analyze the data. Now, this study used 5 CABG trials to sort out mortality outcomes in patients who had had a radial artery conduit, a saphenous vein conduit, or a right internal thoracic artery conduit, in addition to the, what I used to say, LIMA, left internal mammary artery, but now the correct language seems to be left internal thoracic artery, or LITA. The one-sentence background here is that there is a great debate in the surgery world as to what is the best conduit for coronary bypass. I mean, everyone agrees that the left internal thoracic is number one, but then what? Do you harvest the radial artery, the right internal thoracic, or the saphenous vein? Now, the paper, Gaudino et al., Mario Gaudino, this wasn't a typical meta-analysis. That's because the trials had so many different combinations and comparisons. So what Gaudino and his co-authors did is they took 10,000 plus patients in the 5 trials, and they used a propensity matching technique to make triplet groups, about 1,700 patients in each of the 3 groups. One were radial artery conduits, saphenous vein conduits, and right internal thoracic conduits. And of course, propensity matching is a way to use data to find similar patients in a big data set, sort of a method to balance covariates, like in randomization, but nowhere near as effective as randomization. Now, their method for doing this was super complicated, and I don't pretend to understand it, and I don't think it's the point. Their results were very, very, very surprising. They found a 40% lower mortality when radial artery versus vein grafts or right internal thoracic conduits were used. Now, pause there for a second. The choice of conduit after the left internal thoracic artery led to a 40% reduction. Now, to the editors and other surgeons, that seemed implausible. And here's what happened next, and here's the beauty of this. The editors asked Professor Gardino if he would share the data set. And he said, yes, I'll share it. Total transparency. And another group of statisticians at the University College London, led by Nick Fremantle, reanalyzed the same data set. And they found that when they analyzed it the way Dr. Gardino did, the results were identical. So they first showed that there were no errors in that analysis. But Fremantle and his group felt that there were more traditional ways to do propensity matching. And again, I can't say which is better. That's not the point. Fremantle's analytic method yielded no significant differences in outcomes with the different conduits. Again, my friend, it's the same data set, just different choices in analyze it. Now, another academic heart surgeon, David Taggart, along with colleagues, published an editorial on the original Gardino paper and felt that a 40% reduction from a choice of conduit was implausibly large. While he didn't mention this new reanalysis, he explained why it was implausible. And I was drawn to the fact that the reduction in major adverse cardiac outcomes was less than the mortality reduction. And whenever you see that is, overall mortality reduced by more than the cardiac-specific mortality, be on the lookout for some sort of bias, either confounding healthier patients getting one treatment or performance bias or some other bias. Now, I'm going to link to all three of these publications, but I'm absolutely thrilled to report on this. It is such good news. That scientists would share their data for an independent review and that two reviews show conflicting results is so educational. You, of course, know what the answer is now, right? The answer is a proper randomized controlled trial directly comparing the two strategies. So then no one has to make so many varied analytic choices. Okay, so that's it for this week in cardiology. As always, I'm grateful for your support. Thank you. And remember, if you like this podcast, please take the time to give us a rating. Even a 1 or 2 sentence review goes a long way to helping others find us. Until next week, this is John Mandrola from the Heart.org Medscape Cardiology.
You're listening to This Week in Cardiology from the Heart.org Medscape Cardiology. This podcast is intended for healthcare professionals only. Any views expressed are the presenter's own and do not necessarily reflect the views of WebMD or Medscape.